and therefore the growth of surveys and the different kinds of problems that you could begin to understand in a faster and more affordable way. There were probably as many answers as there were people in the room. And the point about that is that, of course, they were all right. But what underpinned, I think, it all was that actually, and I think this is agreeing with Andrew, what you needed were people who were both curious about those scientific and social and economic problems, and were in touch with methodology and computing power and with the way that statistics get produced, the quality of the data and so on, and could collaborate in order to move the whole profession and the academic discipline forward. So for me, I think that's even more true looking ahead. It's going to be about collaboration between different disciplines, collaboration with the media, with users, actually understanding what their problems are, and the ability to problem spot and to problem solve in a way that really, really does make sense. So there's going to be methodological, there's going to be data, there's going to be technological, there's going to be computing, but the essence is going to be how the people who are practitioners, either academic or in other fields, actually bring all that together.
That's a great point, I think, and it kind of leads naturally to our next question, for which I'll begin with Ruth, and that is, what are the three most important things you think that a practicing statistician should know in order to address these future challenges? So what are the three key things? Or it could be two or four.
No, I've got three. I have three.
A few key things.
And it actually builds exactly on what Jill was just saying. I think one of them is communication. Communicating with the people with the data, understanding what problems they have, what's the actual question they're asking. Often people will come with data and they don't even know what question they're asking. So it's trying to tease out specific questions. And then interpreting that into statistical analysis, but then reporting it back in such a way that they understand the answer. Which sounds simple, but often might not be the case. And I think perhaps a recent example of this in the community has been the big explosion of Bayesian statistics. How do you report that back to people when they're so used to p-values? So that's the first one, I think it's communication all round. The second one is computing. Ubiquitous R now. As a simple example, nice tangible example, I don't know a statistician that does not use R. So being able to do some computing skills as well as the most important, I think, of all of them, and this doesn't apply to just statisticians, it's to everyone, is to know your limitations. Know what you don't know and go and ask someone. And that is, I think, across all fields, but I think maybe statisticians are a little bit worse than others for it. Because we know a little bit more than other people, so we think we know everything.
Very fair points. Andrew, what are your thoughts?
I'm torn, actually. I think. So a bit of me thinks that the simple answer from me is stuff. Actually know stuff. And those of you here this morning, I tortured you by asking you a question about the country that we're living in, and most of you got it very, very badly wrong. Not more badly wrong than most people, but I do think that statisticians ought to know the size of the population, the average level of income, roughly what the shape of the income distribution is, what the modal age of death is. My guess is that most of you probably don't know what the modal age of death in this country is. And actually, it's very nearly 90 for men now, and it's above 90 for women. So I think, given that a lot of our job as statisticians in the area where I'm working, which is in kind of public engagement, is about communication, knowing stuff. Really important. Then the other thing I'd say is, perhaps this is only a second thing, is where the data came from, because it's normally pretty grubby. Working at the National Statistics Institute is a little bit like working in a pork pie factory. Once you've done it, you wouldn't always necessarily want to eat it. But it's not. But it makes so it's not. It's not because what's done in national statistics institutes anything other than extremely high quality work. We realise that it's difficult, and actually, whenever the data that it's all too easy to use as statisticians, go back to what Ruth said. Often, if you think about, well, how do we know what the blood sugar level of these diabetic patients was? How have we actually done it? How accurate is the test? All of that's thinking about that, which I think sometimes when we get excited about the statistical work we're doing, we can be dragged away from thinking about what we're actually working with. And I do think that continues to be crucial. And funnily enough, even more crucial as we move into an era of using larger admin data sets instead of surveys. When we were doing surveys, we often were alert to how we were getting the data in, as we rely more and more on data sets that are a side effect of some other transaction, the risks that we don't understand the data well enough.
I think that's a great point. I mean, it comes up in other scientific fields as well. I worked for some time on problems in mass spectrometry, and I stopped working in the area when I realized that the people running the machines couldn't even calibrate them properly. So it makes one question the value of inference that's derived. But of course, the technology changeover is quite quick, and so within 5 to 10 years, the community has moved on to a different type of measurement. We see this in imaging and in all types of areas. Jill, what are your thoughts?
Sorry that I'm going to actually repeat some of this. My foot number one was data. Statistics isn't just about the modelling that comes at the end. It actually encompasses understanding where the data come from, how they've been generated, by whom, for what purposes, what are their strengths and weaknesses, and what does that mean about what you can and can't do with them, and the inferences that you can draw. So get your hands dirty in the pork pie filling, I think is my first one. My second one was exactly the same as Ruth, which was know what you don't know. Because you cannot be experts in everything, and you shouldn't try to be experts in everything. But that leads to my third one, which is, it's not helpful to know who is. So it's about knowing your colleagues, knowing what's happening in the field, knowing who you can ring up, and who you can work with. My three.
Excellent. Thank you. And David?
I'm glad I'm a vegetarian with all this talk about I totally endorse. The short answer is there are not just three things, and I totally agree with and endorse what the previous speakers have said. Communication is essential. Know what you don't know. I mentioned on Wednesday that I give an annual talk on statistical consulting to the MSc students at Imperial, and one of the things I say is you don't know everything. Be prepared to confess, admit that you don't know, and that you'll need to go away and find out and talk to somebody else, because otherwise disaster looms. But the three things that I was going to say, I certainly agree with what other people have said, but the three things I was going to say, which also overlap to a large extent, are first, that real data are unlike textbook data. And the most important thing, I think, is awareness of the imperfections of real data. There's selection bias, there's measurement error, there are all sorts of distortions going on. Be aware of those. In fact, when people bring me data sets, one of the questions I typically ask is, the data set looks perfect. I say, what did you do about the incomplete records? This is often very revealing, because they wouldn't have bothered to mention to me that they'd got rid of a lot of the data if I hadn't asked that question. My second point was that the best is the enemy of the good. This is in the context of statistical consulting to industry, where often an answer, which is good enough for their objectives, to answer their question, is needed within a finite timescale, in a matter of weeks perhaps, rather than waiting for me to spend 2 years on it, giving them the mathematically optimal solution. And the third thing, coming back to data, is that data are critical. And I learned this, I can remember, I was building a screening model for osteoporosis. And the thing is that no matter how clever your neural network or support vector machine or other statistical model, if the data don't have predictive value, the models won't be able to predict. It all comes back to data, I think.
Thank you. I think we got a pretty clear consensus emerging there. What I'm going to do is I'm going to ask one more question of our panel before opening it up to discussion. or at least the first round of discussion. And I'll start with Jill, and I'll ask the fourth question on the list here, which is something we've heard a little bit about already, and that is as follows. There's been a lot of discussion in recent years about emerging areas such as machine learning in the early 2000s, more recently data science, to name but a few. Others like bioinformatics come to mind as well. Do you think these areas like machine learning or data science, do they encompass all of statistics or vice versa? What do you think the future landscape looks like for these sort of sets of disciplines that are clearly intellectually related but not necessarily the same?
I think you're asking the wrong person. So following my own advice, in the sense that I'm not an academic statistician. I'm a practitioner and a producer of official statistics. And actually, I get a bit bored about thinking about the separation of these disciplines. Data scientists, they need to be more like statisticians. Well, actually, statisticians need to be more like data scientists. I'm not sure how fruitful that discussion is. What there is to me is a set of problems that we can, with a range of skills, which includes some of the things that we are beginning to think of as data science, but certainly includes the range of skills that I think of as being statistical skills, statistical thinking, which encompasses data, it encompasses inference, it encompasses understanding the limitations and the strengths, and using technology in ways in which we can address some of those problems. So again, this to me is back to how do we identify those things that we have in common that we can each bring to the table and collaborate in a way that will address the pressing issues that we have.
Thank you. Now, Andrew, I know this is something that you've thought about in the context of the UK Statistics Authority and the government's own attempts to sort of upskill or reskill its workforce around areas like data science. What's your perspective?
So, one of the things we're doing at the Statistics Authority at the moment is we're creating a data science campus, and I think that's a really important and good thing to do. But I think the thing I want to say about this area is very